We're going to look at the results that you would see if you were to test different substances with red litmus paper, blue litmus paper, and Congo red test paper. So I'm going to start with the red litmus paper. So I have this little sheet of paper, and we can put a drop of a substance on there, and it may just leave the red litmus paper red, but it also could change that red litmus paper blue, depending on the properties of that particular substance. And so I'll start with this first solution that I've got, and you see that I put it on that red litmus paper, and that paper is turning blue. And if I use a different substance, I put it on the red litmus paper. Now what you see is there's no real change, it's just wet. So it didn't change colors. And so that's what you see when you use red litmus paper. A substance is either going to have no change with the red litmus paper, or it's going to cause that red litmus paper to turn blue. Now, another type of litmus paper we can use is blue litmus paper. So blue litmus paper, as it sounds, starts blue, and so it's kind of this light blue color. And you could test a substance, and it could cause that blue litmus paper to have no change. Okay, so it's still blue. It looks a little darker now just because it's wet, but there's no actual change in the color. But I can use another substance, and this substance is causing that blue litmus paper to turn red. And so those are the two different things you would see with blue litmus paper. Either it has no change or it changes to red, depending on the properties of the substance that you're testing. Okay, and then we have another type of test paper, and that's called Congo red test paper. And so I could test that with a substance, and it could have no change. So again, it kind of looks darker, and that's only because it's wet. So there's no actual change in that paper. But if I test it with another substance, it could cause it to change blue. And so that's what you would see with Congo red, is that that Congo red test paper will either have no change with the substance, or it will turn blue. And that again depends on the properties of the substances. And specifically, you use these types of papers to understand acid-base type characteristics of the substances. Now we're going to look at 3 more tests we can use to help us understand a little bit about the acid-base characteristics of a substance. We'll use 3 different liquids and see the different types of reactions that you would observe from these. So I've got 2 test tubes here with 2 different solutions. They have different acid-base characteristics. And then I have some phenolphthalein. And so this is a common indicator we would use in acid-base chemistry. And so I'm going to add a few drops of this phenolphthalein to each test tube, and we'll see what changes. Okay, and you should be able to see right away that the one on the left is really a bright pink, and then the one on the right didn't really change. It's clear. It's maybe a little bit cloudy in there, but in general you don't see any kind of change to that. And so that's your 2 kind of observations for phenolphthalein. Either there's not a color change, or you'll see a pink color from a substance. Now I've got 2 more substances here, and we're going to test these with an alizarin yellow R. So this is another type of indicator. This indicator starts out yellow, and it can change depending on what type of substance you add it to. So again, I'll add a few drops to each test tube. And then kind of shake that a little bit. Now these both started out as clear solutions, and what you can see is the one on the left is kind of a reddish orange, and the one on the right is yellow. Now the yellow, of course, comes from that indicator, which starts out yellow. It's a little bit lighter because it's diluted. But on the left, that's an interaction with the substance in there that causes that color change to that reddish orange color. And so that's what you would see with the alizarin yellow R indicator, is either you see no change or just the yellow color from the indicator, or you see it change to a red or possibly orange type color. Okay, so our final test, we're going to take 2 clear solutions here. We're going to test them with sodium hydrogen carbonate or sodium bicarbonate, and that's because when we have carbonate substances or bicarbonates, when they react with some substances, they'll form CO2 gas, and that all depends on the acid-base characteristics. So I'm going to add a few drops. Now I'll do 1 tube, at a time slowly. So this first tube on the left, I'm adding that, and you can see as I'm adding it, there's bubbles forming. And even when I shake it, some more bubbles form. And so that's what we're looking for what we would call a positive test of that. And then if I do it to the tube on the right, now this one you can kind of see a little bit of swirling there. That's just mixing of the different densities, but there weren't ever any bubbles forming in that one. So those are kind of your 2 results for when we add a bicarbonate solution to something. It'll either not react or it'll form those bubbles forming CO2 gas.